And if it wasn't, we had a formula we could use for finding the vertex. So let's see if we can answer these questions. If I asked you to find the vertex of this, what was the formula we used? Good. So to find the x value of your vertex, you always did the opposite of b over 2a. And we all know what I mean by a and b. B is the coefficient of x, so that would be a negative 6, over 2 times the coefficient of x squared. So we get negative 6 over negative 6, which is 1. Right, but a vertex is an ordered pair. We have the x value. How do we get the y value? Here is our function, the formula. I know my x is 1, so we plug the 1 in.
What? I'm not getting this.
So if we plug that in, we get. Was it notes handout? What is the axis of symmetry? 1. Except the axis is a line, so you have to give me the full equation of the line. X equals 1. Alright, how do I know if this opens up or down? If it's a negative, it opens down. Positives open up. Alright, why don't you guys take a second and see if you can get the others. Find your vertex, axis of symmetry, if it opens up or down. Alright, so for this one, opposite of b would be positive 8 over 2 times 4. So we get 1. Plug in 1. And we get 3. So vertex is ordered pair 1, 3. Axis is x equals 1. Open up or down? Up. Good. Last one, opposite of b, so 4 over 2 times negative 8. So negative 1, 4. And if we plug that in, we get negative 19 over 2, or negative 9.5. So our vertex is order pair negative 1/4, negative 19 halves. Axis, x equals negative 1/4, and this one opens down. So does it have a maximum or a minimum? Maximum, but opens down, it has a max. Are we okay with those? Sometimes we don't care what the actual solution to a quadratic is, we just care how many they're going to have, or if I'm thinking about the graph, how many times would it hit the x-axis. And so we can use the discriminant to do that. That comes from the quadratic formula, the opposite of b, plus or minus the square root, b squared minus 4ac all over 2a. The discriminant is the thing under the square root. So if that's a positive number, then you have something plus that and something minus that. And so what it means is there are 2 real solutions, or 2 two x-intercepts. When you look at that graph, it would hit the x-axis twice. If it's 0, think about if I said like -5 plus or minus the square root of 0 over 2. What happens when you add and subtract 0? Get the same thing. So it only has one real solution. In terms of a graph, it means it hits the x-axis one time. What about if it's a negative? What happens if you have a negative under a radical? It's imaginary. So that means it has no real solutions. They are imaginary. In terms of a graph, that means there is no x-intercept. You have a quadratic that never hits the x-axis. So it's possible for a quadratic to hit the axis once, twice, or not at all. Have your book handy. If not, scoot over by somebody that has one. I want to look at a problem. Also, make sure if you are borrowing a textbook in class, make sure they don't leave the classroom. I've had 2 go missing last week. So check if you might have 2 of my textbooks instead of just the one, please. Alright, this one says, find a quadratic function whose graph matches the one in the figure. Alright, so we have a graph here. We need the equation that goes with it. I think it's easiest if you think about it in terms of like your vertex form. Your a x minus h squared plus k. Can you tell me what h and k are here? Yes, the h and k are the x and y of the vertex. So my h is 2, my k is -1, so -1. So my formula, I know just by plugging in my vertex, we have an x minus 2 squared minus 1. The only other thing this might have is a number out in front. So we need to figure out if it does. That's where the other point on our graph comes in. So it tells me that 0, 0 is a point on this graph. So if I plug that in for my x and my y, so f of x is like my y, my x is 0, (0 minus 2 is -2, squared is 4. So that gives me a 4a minus 1. So if I add over my 1, divide, a is 1/4. So now I know my full equation. My function is 1/4 times x minus 2 squared minus 1. So if you have to write the equation from the graph, start with the vertex, and then find another point on the graph you can plug in to see if there's a coefficient in front. Any questions on that one? Then back notes handout. The last thing I want to talk about is quadratic models. We've seen word problems. Quadratic equations are used a lot in word problems because the vertex gives us a maximum or a minimum. So in these, your vertex is always either the max or the min. How do we decide if it's a max or a min? If it opens up or down. One form that we will use a lot is this equation for height of an object. You might have seen it in a science class before. I'm not going to make you ever memorize that formula. I would give it to you if you needed it. V sub 0 just means velocity at time 0, also called your initial or your starting velocity. H sub 0 is your height at time 0 or your starting height. T is your time in seconds. And then that whole thing, the S of t, gives you a height at a given point in time. So, I would never make you memorize that formula, but we should be able to use it in a problem. A ball is thrown directly upward from an initial height of 75 feet with an initial velocity of 112 feet per second. RA. Give a function that describes the height of the ball in terms of time t. So this is the formula you just wrote down. So you had your S of t equals, so we're just copying this down for a second and then we'll plug in what we need. V sub 0 is my starting velocity. What was that? What is my H sub 0, my starting height? What if I said you started on the ground? What would your starting height be?
0.
Okay. Alright, so that gives me a formula for height where time is your variable. That's all we were asked to do on part A. Part B. After how many seconds does the projectile reach its maximum height? What is the maximum height? What am I asking you to find? The vertex. How do we find that? Opposite of b over 2a. So the opposite of b over 2 times a and we get 3.5. What does 3.5 represent? That's the x, which in this case our variable was t, which was time. So, after how many seconds does it reach its maximum? It's after 3.5 seconds. What is the maximum? So you just have to plug 3.5 into your formula. And then this, our height was measured in feet. So those are the types of questions that I would ask you on your homework, test, or quiz. But I do want to go ahead and look at part C. So I'm not going to assess you on these because you don't have graphing calculators on your test anymore. However, it is still something that sometimes shows up on an ACT, so I thought I might show you guys a trick on your graphing calculators to help you for that. So if it asks me, for what interval of time is the height greater than 200? So I'm trying to find my time. This is my equation. And I want to know when that is greater than 200. Now, we could work through and solve that. We would have to bring over the 200, factor, and make a sign line. So we could, but I wanted to show you how to use your calculator on this. So grab a graphing calculator if you don't have one. And I'm going to go to my y equals, and I'm going to type in this equation. You can't use the variable t, you just have to use x squared. So for my y1, I type in the left-hand side, negative 16x squared plus 112x plus 75. And I'm going to go ahead for the second one, I'm going to type the other half, equal 200 for my second part. Okay, so if I just graph this, if you want to reset any funny settings on your calculator to make sure we're all at the same place, you can hit zoom number 6. That resets it. Okay, so here's my graph. Your calculator, when you just graph something, unless your settings have been changed, it graphs it from negative 10 to 10. Okay, I'm seeing this equation, but I'm not seeing when it hits a height of 200, right? Because my height was only 10. Okay.
Yeah, mine says quit as well.
I can fix that. Alright, is anyone else's calculator?
Right now. Do you need a phone or head with the veil? Yeah, you need to get a veil. I am.
Alright.
Oh.
Blame it on my stats kids. When they graph something, they don't get a stat plot, then it won't graph the regular stuff. It's all their fault. There you go. Alright. So if we want to see this, we can adjust our graph to show us a higher value. There are several ways to do this, but I want you to just push this window button. I need my y's to be higher. I'm trying to go up to 200, so I want to at least go past that. So maybe I want to go to 220. Your y scale, that's what it counts by, so it's counting by 1, which is fine. But if I'm going all the way up to 220, counting by 1, that might take a bit. You can change it if you want, make it like a 10, just so it counts faster. So I changed my y max to 220 and my y scale to 10. And then hit graph. Okay, so what I'm seeing, we want the places, can we agree it would be above 200 between these 2 points? Okay, so we just need to find those. Your calculator can do that. If you go to second, and then the trace button. Did you get it? This is all the stuff it can find. We want to find where two things meet, so that is intersect. Okay, then it's going to ask me questions. You know, it says first curve, and at the top it's showing me it's on the parabola. Just hit enter. Second curve, it automatically jumps to my line. Just hit enter. The one that's important is guess. You have to tell it where to look. So just get close to the point you're trying to find and hit enter. Alright, and it should tell you about 1.39.
I don't know how to get.
Because you haven't hit enter.
Yeah, I did.
You didn't do so.
Oh, I did.
So it's asking you a question.
Okay, I don't know what I did. You need to wear glasses if you can't even read your calculator. No, I can read the calculator. No, I just need to
Okay,
read
and then your guess you said. Alright.
It's supposed to be.
Mine's
1.489.
Girl. Sorry.
Alright. So we found the first one. So it's between 1.39 seconds. And if you want to find the other one, you just do it again. So second, trace, intersect. First curve, your calculator does this automatically. Just hit enter. It's asking me for the second curve. It does that automatically. Hit enter. Guess, this time I need to get closer to this point over here. And hit enter. So that's about 5.61 seconds. Now, am I going to put this on your test? No. Am I even putting this on your homework? No. But it is a helpful feature to know that your calculator can do for you, especially on things like the ACT. So I don't just want to skip it. Is that okay? Let's go ahead. We'll do this last one and then I'm done. So if it asks after how many seconds will the ball hit the ground? Tell me some different ways of doing that. If the ball hits the ground, what's your height? 0. So I could set my equation equal to 0. Okay, could we do the quadratic formula or something to solve that? Yes. Could we do it on our calculator? Yeah. If you wanted to, there's actually several different ways your calculator will do it, but if you want to do it the same way we did the last one, thank you. All you have to do is change this y2 to a 0. If you want to do it the exact same way. Thank you. Then if we look at the graph, we're just finding these 2 points. Now, would this one be reasonable? No, that's a negative. Time can't be negative. So I'm just looking for this one, right? So we could go to second, trace, intersect. First curve, your calculator does it. Just hit enter. Second curve, hit enter. Guess. You have to move to this point over here on the right and hit enter. And you get an intersection at 7.615. So about 7.6 seconds. So just some helpful tidbits.
This is for the ACT.
Yeah, I'm not going
I
to.
don't. Well, I'm gonna take it again in December, and then I'll take it again in April.
All right.
Oh, yeah.
So we are at the end of this section. I gave you guys problems Friday. You can add this to them, and you have quite a bit of time right now to work on this.
Check my email.
You have to put a picture of your face.